Namaste everyone, hope all of you are well. In lecture 4 already I have described about the extensive and intensive property, enthalpy. We have solved some of the numericals also. See, whatever we are studying, it's just related to the energy, heat, work. In the first section we have just learned about the system and surrounding, work, heat, first law of thermodynamics, the equation of thermodynamics, delta U is equal to delta Q plus delta W. After then, as we have moved towards the enthalpy, how the enthalpy changes in the reaction, in the reversible and irreversible. We have talked about the work in the reversible work, what will be the value when the volume is constant, when the pressure is constant. As we have moved ahead after the enthalpy, then we have talked about the reversible and irreversible work done. Then we have talked about extensive and intensive properties. And in this video, we are going to discuss about a new state function called enthalpy change. So this whole chapter is related to the energy only. And in this chapter, no new thing except energy. See, in the energy you can just read in the form of heat. In energy you can just go through in the form of work. Enthalpy, new topic will come, entropy, Gibbs free energy, Hess law. Everywhere we will discuss only and only about the energy. So there is no need to worry little bit also about it. घबराने की बिल्कुल भी बात नहीं है, क्योंकि जब भी आप कोई नया चीज़ सीखते हो, whenever you learn a new thing, what happens that time we get more and more excited, and some students lost their concentration also. So what is this? I'm not able to understand this and that, so many things. But I'm telling you, there is nothing new. Whatever we have studied, it is going to be repeated in the extended form. Whenever you know the basic, as you move to the extended form, it's very easy. Let me tell you one story about the system and surrounding. See, our body, our whole body, this is called surrounding. And inside that, there is one system called sound. Sound do not affect whether your body bath or not. Are you understanding? If I eat, my body get nutrition, not my soul. As my soul is just an energy form. Energy can neither be created nor be destroyed. It is already explained in the Gita also. That similarly, if we talk about the soul, Atma, it can't be created and it cannot be destroyed. Just transfer from one body to another body. Similarly, this whole system, this is body surrounding, and that soul is our system. The system, inside that system, the energy transformation, how the energy goes into the adiabatic process, isothermal process, and then all the things, as we have seen that how this heat changes, how the value of Q at the constant volume and constant pressure, how the volume increases and decreases, what are the differentiation in the volumes. These are all the things already we have discussed in the lecture number 1, lecture number 2 and lecture number 3. In this video, this is the lecture number 5. In the lecture number 4, in the previous video already I described you about from the extensive and intensive properties, right? And in this video I am going to tell you about the enthalpy change. How this enthalpy is being changed. Already I have discussed about the new function that was enthalpy, and in this whole video I am going to tell you about the enthalpy change. Now question is, where it will change? System to surrounding, surrounding to system, or where? Now question is that whenever you talk about any of the chemical reaction, in the chemical reaction two things are there, reactant and products, right? Reactants and products. Just suppose I am taking one reaction, that methane is when burnt, it produces carbon dioxide and water, right? CH4 plus 2O2 gives CO2 plus 2H2. Now, have you ever thought that this enthalpy change, how much enthalpy has been changed in the reactants and products? So here the enthalpy change is denoted by delta HR. What is the formula of this delta HR? Is the sum of enthalpy changes in the product minus sum of enthalpy changes in the reactants. How much there is a change in product minus how much there is in the change of reactants. So that differentiation is called enthalpy change in any chemical reaction. In any chemical reaction, when you talk about the reactant and products, so definitely from the reactant to product it is being, then there will be a change in enthalpy. But how much in the reactant side and how much in the product side? So whatever the value of the product side is there and whatever the value of the reactant side, you have to just do the difference between these two. You will get the change in enthalpy. As you can see here, I have taken a reactant also and I have taken a product. Methane plus 2O2 gives you CO2 plus 2H2. Right? So here if I talk about what are the products? Products are carbon dioxide and water, and what are the reactants? Methane and oxygen. Right? So here you can see this HM is called the molar enthalpy. What is called? Molar enthalpy. Molar enthalpy of this CO2 and 2H. That is the molar enthalpy. And here H2O is there in the liquid form in the product side. This is the sum of the enthalpy of product minus the sum of the enthalpy of reactants. Right? So this is the thing, see, whenever you get something new now, that time your brain should be fully calm, fully peace, then only you will be able to understand a new thing. So in this new thing I have given you that enthalpy change. How much it has been changed, as already you can see here. After understanding this molar enthalpy, HM is the molar enthalpy. Now you should know that enthalpy change is a very useful quantity. What is enthalpy change? It is a useful quantity. It is not a general quantity, it is a useful quantity. Knowledge of the quantity is required when we need to plan the heating or cooling required to maintain an industrial chemical reaction at a constant temperature. It is also required to calculate the temperature dependence of equilibrium constant. See, whenever if I talk about the reactants and products, that time you must have a question in the mind. Sir, in this reactant and product, whatever you have done, have you ever discussed about the temperature, pressure and volume? You can ask me here, say why I have said you these all the things. This is a normal enthalpy change. But if I talk about standard enthalpy change, that time I have to fix you at the temperature, this much Kelvin is fixed here at 298 Kelvin or 299 or 300 Kelvin, whatever the Kelvin I am giving you, standard enthalpy change it will become. This is a normal enthalpy change in which you should know in a chemical reaction, either from the reactant side or in the product side. Whatever the enthalpy change has been happening, the sigma denotes the sum of the products and sum of the reactants. So that's why I have written here, enthalpy change is the summation of products minus the summation of reactants. Are you getting or not? Whatever I mean to say is just and just upon the reaction-reaction enthalpy. It is a normal reaction-reaction enthalpy. After understanding this concept, I will talk about the standard enthalpy of reactions. Now, what is the standard enthalpy of reactions? Do you know what is the standard enthalpy of reactions? Standard enthalpy reactions. Okay, so can you tell me what is the standard enthalpy reactions? I hope you know also about the standard enthalpy reaction. The standard enthalpy reaction is the enthalpy change for a reaction when all the participating substances are in the standard state. Means if I talk about the reactants, they must be in the standard state. Now you can ask me, sir, what is the standard state? Yeah, definitely you can ask me, what is the standard state? The standard state of a substance is specified by its temperature. Its pure form at 1 bar pressure and 298 Kelvin. If I talk about ethanol, take any substances. If I talk about this marker, just suppose this marker, inside this marker I am having a blue color ink, black color ink. In this black color ink, have you ever thought at what temperature and what pressure it has been fixed. See, in the previous few days, my ear had got a hole, and when I visit to a doctor, ENT specialist, he has first what he has done, he had cleaned my ear with a great pressure. Great pressure means he had applied the pressure at very high pressure. There was a machine. He has put that pressure into my ear. Whatever the infections, bacteria, everything came out. Why I am talking to you these all the things? Because that was a normal reaction. But right now we are talking about the standard enthalpy reaction. In the standard enthalpy reaction, everything is in the standard form. At the pressure, at the temperature, everything. So that's why I talked to you. The standard enthalpy of the reaction is the enthalpy change of the reaction when all the participating substances are in their standard state. And standard state, right now only I have said you, at a fixed temperature and pressure. The standard state of a substance at a specified temperature is its pure form at 1 bar. For example, if I take about the liquid ethanol, C2H5OH liquid, ethanol. Can you tell me how it will be standard form? Just suppose, just put an idea. Standard 298 Kelvin, 298 Kelvin and 1 bar pressure. This is your temperature and this is your pressure. Now tell me, what is the difference in the standard enthalpy change reaction and the reaction-reaction enthalpy? Because at 298 Kelvin there is a pure liquid ethanol, and if I talk about the standard state of solid iron, that is 500 Kelvin is pure iron at 1 bar pressure. 500 Kelvin. If I talk about a solid iron, here the temperature will be 500 Kelvin and the pressure will be 1 bar. So now these are also standard form, the standard states of these substances. So here, as you have seen about the standard enthalpy reaction, say enthalpy changes during the reaction. You know very well why it changes, because when you do a reaction in a chemical reaction, definitely when the two reactants react with each other at a certain temperature, pressure, then they give a product formation. And in the product formation also, there may be 1-2 products. So there will be a change in enthalpy. If there will be a change in enthalpy, then that was a normal change in enthalpy. But if we talk about the standard change in enthalpy, then the temperature and pressure will be fixed, as I have told you about the alcohol liquid form, and if I told you about the iron solid form. Got it, everyone? Is there any doubt during this discussion? Now I will go ahead with the enthalpy changes during the phase transformation. Now there will be a new thing, enthalpy changes during the stage formations. Our new topic is enthalpy changes during the phase transformation. Enthalpy changes during the phase transformation. Here the word, nothing is new. Now as you have heard about the enthalpy change, you have already know what is enthalpy change. Now there is a phase transformation, as you may have seen that ice, right? Ice changes to water and water to water vapor, right? Now just suppose this ice is in the solid form, this liquid is in the solid after then liquid, and this is gaseous form. Now you just suppose all the formula is H2O only, either it is in solid and liquid or gaseous. Now there is only what there is a phase transformations. What is that? There is a phase transformation. Now definitely I have already informed you, if there is a reaction from reactant to product, if it is being, then definitely there is a change in enthalpy. Then if I talk about the phase transformation is also because of the rise of temperature, right? As you know very well, ice can't be directly, if I put the ice at 0 degrees Celsius, is it going to melt? No, it's not going to melt. It is going to remain at the same temperature. It is in the ice cube form only, right? As I have increased the temperature from 0 degree to 30 degree I have taken, then it became the liquid water. And from 30 degree to 100 degree I have taken, it became gaseous form. So now question is about the phase transformation is also involving the enthalpy changes. What does it involve? It involves the enthalpy changes. Just suppose that as the ice started melting, normally it melts because of the atmospheric pressure and the temperature. You know very well, we generally compare 1 bar atmospheric pressure and 25 to 30 degrees Celsius or the room temperature, right? So but 273 Kelvin, right? 273 Kelvin constant, if you put the temperature, then what happens? Have you ever thought? As I have told you, there will be a fuse. 273 Kelvin, 0 degrees Celsius. Now if the temperature is constant, now just suppose from solid to liquid it will be fused, now solid to liquid, as a ice to liquid, H2O solid to H2O liquid. Then you will ask me, sir, how much enthalpy has been changed? So I am giving you the value of this fusion, delta H fusion. How much? From solid to liquid, from ice to water. You can ask me, sir, how much this enthalpy changes has been taken? That is 6 kilojoule per mole. 6 kilojoule per mole. This is the enthalpy changes during the fusion from a solid to liquid. That is 6 kilojoule per mole. Now you can ask me, sir, what is this delta H minus fusion? You can ask me, this is nothing else. This is the enthalpy of fusion in the standard state. Enthalpy of fusion in the standard state when it changes from solid to liquid, right? Or you can see that if water freezes, the process is reversed and equal amount of heat is given to the surrounding. Means if this again liquid will change into the solid, the same amount of fusion will be given to it, then again it can convert into the solid. अब खुद सोचो, दिमाग लगाओ, पानी रहता है हमारे घर में नॉर्मल में, आपने फ्रीज़र के अंदर में उसको डाला, वो बर्फ़ बन गया, बर्फ़ को वापस आपने निकाला, फिर से पानी बन गया, पानी को वापस आपने फ्रीज़र के अंदर में डाला तो बर्फ़ बन गया. कभी कुछ दिमाग में ख्याल आया कि क्या हो रहा था? Enthalpy was changing in the phase formation from solid to liquid, liquid to solid. आपने ये दिमाग नहीं लगाया कि कितना फ्यूजन उसके अंदर में, डेल्टा एच फ्यूजन की वैल्यू कितनी. देखो ये सारे चेंजेस जो होता है वो हमारे इर्द गिर्द नहीं होते, कुछ अलग नहीं. अब सीधा सीधी समझ, एक बात मैं बताता हूँ आपको. आपकी मम्मी बाजार से सब्जी लाती है, राइट? पोटैटो, टोमेटो, जो भी आप लोग सब्जी खाते हो, कॉलीफ्लावर, कैबेज वगैरह वगैरह जो भी है. कभी आपने सोचा कि रॉ वेजिटेबल हम क्यों नहीं खाते? कुछ सैलड्स होते हैं जो खाते हैं, जैसे मतलब कैबेज हो गया, कुकुम्बर हो गया, टोमेटोज हो गया, ऑनियन हो गया, कुछ रॉ तो हम खाते हैं, बट एवरीथिंग रॉ यू कांट ईट रॉ पोटैटो। उसको हम लोग क्या करते हैं, या तो बॉईल करते हैं, अदरवाइज डायरेक्टली फ्राई करते हैं सब्जी में, उसके बाद जैसे ही वो सीज जाता है उसके बाद हम लोग उसको खाते हैं। ये क्या है? हैव यू एवर थॉट व्हाट इज दिस? ये पक जाना मतलब सब्जी को हम लोग पकाते हैं, फ्राई करते हैं, व्हाट इज दिस? Enthalpy changes during the phase transformation. उसको हमने हीट दिया, एंथैल्पी चेंज हुआ, फ्यूजन हुआ, कितना हुआ, बस वही कैलकुलेट करना है। देयर इज नथिंग एल्स। कुछ अलग नहीं है जो हमारे डेली लाइफ में जो घटनाएं घट रही है, व्हाटएवर द फेनोमेनन्स आर हैपनिंग इन आवर डेली लाइफ, द सेम थिंग वी आर रीडिंग। एज राइट नाउ ओनली आई हैव टोल्ड यू अबाउट दैट आइस क्यूब्स। जस्ट सपोज a student was watching IPL 2020. In his favorite team was there CSK versus MI. ओके, चेन्नई सुपर किंग और मुंबई इंडियंस, दोनों टीम आपस में भिड़न थी। उस बच्चे को कहीं पर जो है मतलब एक छोटा सा यहाँ पे उसको किसी ने सजेस्ट किया दैट यू शुड रब विद आइस क्यूब। उसने बहुत किया, सेम थिंग, उसने फ्रीजर से आइस क्यूब निकाला एंड ही हैड पुट इन टेकन इनटू अ बाउल एंड हिंस मैच चल रही थी, वो भूल गया रब करना था। नाउ व्हाट विल हैपन, that you will see that ice cube has melted and it has formed into the water. Phase transformation ना, enthalpy changes ना। अब वो क्या करेंगे, वापस जाएगा अंदर में, देखेगा बर्फ है कि नहीं होगा तो वापस इस चीज़ को वापस रख देगा, फिर आधे एक घंटे के बाद मैच खत्म हुई, 1 घंटे के बाद 2 घंटे के बाद वापस निकालेगा, फिर अब करेगा। I am not saying you these things happen. I just want to inform you about the enthalpy changes. How do enthalpy changes? हमारे सराउंडिंग में किस तरह से इंथैल्पीज में बदलाव आते हैं। आपको जैसे मैंने स्टार्टिंग में सिखाया कि रिएक्टेंट प्रोडक्ट, रिएक्शन करेंगे, प्रोडक्ट बनेगा, एंड आफ्टर बिकमिंग अ प्रोडक्ट हाउ मच इंथैल्पी चेंजेस विल बी देयर, द समेशन ऑफ रिएक्टेंट्स इंथैल्पी चेंजेस इन द रिएक्टेंट साइड एंड द समेशन ऑफ इंथैल्पी चेंजेस इन द प्रोडक्ट में से रिएक्टेंट को माइनस करेंगे, व्हाटएवर द इंथैल्पी चेंजेस या अपॉन डेल्टा एच आर की वैल्यू हम लोगों को मिल जाती थी। सिमिलरली एज आई हैव टॉक्ड अबाउट द स्टैंडर्ड इंथैल्पी चेंजेस एट द स्टैंडर्ड टेम्परेचर एंड प्रेशर, and right now I am talking about the enthalpy changes during the phase transformation. phase transformation का सीधा सीधी मतलब समझ जाना, सॉलिड से लिक्विड, लिक्विड से गैसेस, सॉलिड से लिक्विड या फिर लिक्विड से गैसेस। अब मान लो तुम्हें वही सेम रिएक्शन में बता रहा हूँ, यहाँ पे जस्ट एक आइडिया लगा लेना कि ये तो मैंने सिर्फ सॉलिड से लिक्विड किया था, बराबर, जस्ट H2O का ही लो, अब पानी को ही लेते हो तो पानी का ही लो। अब H2O सॉलिड से लिक्विड बना और लिक्विड से सॉलिड बना, तो इसमें तुमने देखा कि 6 किलो जूल पर मीन्स here H2O was solid and it has converted into H2O into liquid, right? So that was 6 kilojoule per mole. अब मान लो H2O लिक्विड है, बराबर, और H2O अब तुमको गैसियस मतलब वेपर फॉर्म में कर रहे हैं, वेपराइजेशन कर रहे हैं, राइट है। तो डेल्टा H जो वेपर है, यहाँ पर ये दो चीज़ हो जाते हैं, वेपर और गैस, क्योंकि अब स्टैंडर्ड तुम लोगों का बढ़ रहा है, इसलिए तुम लोगों को थोड़ा सिखाना ज़रूरी है। सो फ्रॉम H2O लिक्विड टू H2O वेपर, इसको चेंज करने में कितना डेल्टा H की वैल्यू लगेगी पता है तुम्हें? इसमें तुम्हें 40.79। Now you will ask me, sir, how this possible? Because you know very well solid to liquid general temperature pressure, right? But a liquid to vapor, you have to give a high rise in temperature. So definitely there will be a great changes in the enthalpy. So that's why here it is 40.79. Okay, and here it will be the plus only, everywhere plus only. So as you are increasing the temperature, then you can say here these are nothing else. These are delta H vaporization's value. Okay, both are delta H vaporization's value. Now you can ask me, sir, the standard enthalpy of vaporization, standard enthalpy of, यहाँ पर दो चीज़ आप पूछ सकते हैं। ये जो है standard enthalpy of fusion होगा, here standard enthalpy of fusion, and here standard enthalpy of vaporization. Remember this one. Means here solid to liquid there will be a standard enthalpy of fusion, and from liquid to vapor it will be standard enthalpy of vaporization. The amount of heat required to vaporize 1 mole of a liquid at constant temperature and under standard pressure is called standard enthalpy vaporization or molar enthalpy of vaporization. याद रखना बच्चों, standard enthalpy of vaporization या molar enthalpy of vaporization. Have you heard this word, molar enthalpy of vaporization? That is nothing else as a standard temperature and standard pressure when a liquid converts into vapor. That amount of enthalpy is called molar enthalpy of vaporization. Here I am talking about 1 mole. How much? 1 mole. It's not greater than 1 mole. I am talking about here 1 mole. So standard enthalpy. One more thing you can ask me, sir. Can this be directly this solid to vapor? Means you can talk about camphor, burning a camphor. What's that method called? Sublimation. Have you remember the word? Sublimation, yes. Standard enthalpy of sublimation, you can ask me. So what is standard enthalpy of sublimation? Standard enthalpy of sublimation. Have you heard this word or not? Yes, you may have heard, definitely you may have heard. Solid into vapor, solid carbon dioxide. Yes, solid carbon dioxide. Or dry ice, you know. When the sublimation of direct conversion from solid to vapor, direct conversion from solid to vapor, and in which the enthalpy, whatever the enthalpy changes, that's called standard enthalpy of sublimation. If I talk about dry ice, solid carbon dioxide, जिसका दूसरा नाम dry ice है, and when this solid carbon dioxide sublimates at 195 Kelvin with delta H sublimation, that is 25.2 kilojoule per mole. अब आपको कोई पूछेगा जो ये ड्राई आइस होता है, सॉलिड कार्बन डाइऑक्साइड देखा है आप लोगों ने कि नहीं देखा? आई होप सबने देखा होगा. देखो, whenever we go in an annual function, you will see on the background stage some vapors are coming. That is nothing else, that is solid carbon dioxide. What is that? Dry ice. And when this sublimates when it changes into the vapor form, it requires 195 Kelvin temperature. How much? 195. And now you can ask me, sir, here the delta H sublimation, what will be the value of this enthalpy changes in the sublimation? Then I am telling you, from solid carbon dioxide, when it sublimates, it gives 25.2 kilojoule per mole. 25.2 kilojoule per mole. Okay, how many of you are very excited to keep your clothes very safely? You know, we have a lot of uniforms, a lot of clothes, a lot of t-shirts, shirt, pant. So what happened? We keep our clothes, and while keeping our clothes, we put naphthalene balls. Yes? Why? That in our clothes there should be not some, means bacteria should not, or fungal should not infect our clothes. So that's why we keep naphthalene balls. So this naphthalene also convert into the gaseous, means solid to directly to the gaseous at standard temperature and pressure, 1 bar pressure and the normal temperature. So do you know how much it requires? Naphthalene sublimates slowly. Delta H value is 73 kilojoule for naphthalene. Okay, remember for naphthalene. This naphthalene sublimates at sublimation is 72 kilojoule per mole. So remember, dear student, about the enthalpy changes during the formations of phase formation, solid to liquid, liquid to gas, solid to gas, solid to vapor. Means whatever the changes you are getting, there will be a change in enthalpy. How much change in enthalpy I have written here? From solid to liquid, liquid to gas. You can take any example. See, we do not understand about the delta H value, but we do daily applications. Have you ever thought that, just suppose you are charging your mobile phone per day, as it battery gets over, what do? You do charging. Have you ever thought what is the enthalpy changes in that? No. You don't require, but here you require, you get a value. You have to understand this enthalpy changes. Okay, everyone? I hope the magnitude of enthalpy changes depends upon the strength of the intermolecular interactions. Yeah, one more thing. Where this enthalpy changes, it depends upon the intermolecular interactions. Means the atoms and molecules which are tightly held with each other, means in the solid form or liquid or in the gaseous form, it's a phase transformation. If I talk about the strong hydrogen bonds between the water molecules, hold them tightly in the liquid phase. For an organic liquid such as acetone, the intermolecular dipole-dipole interactions are significantly weaker, thus it requires a heat of vaporization of 1 mole of acetone than it does vaporize of 1 mole of water. Yeah, if you want to understand about all the things, all the gases vaporization, it is given in your NCERT textbook in table 6.1 as the nitrogen standard enthalpy change from the fusion, that is 63.15 kilojoule per mole. You have, means in the 6.1 table it is given about some of the gases. You can just go through it and you can understand about this changing curve. Now I am going to write one numerical. During this numerical, I hope that you will understand about this enthalpy changes. Whatever we are studying, it is comparable to our daily life, whatever you are doing. See, nothing is outside of the world. Whatever we are studying is inside the world only. And whatever you are doing, it's already being with you, because science is the subject of experiment. And especially if I talk about the chemistry, it is an experimental subject. All the experiments have been done, then you have got the values that how this carbon dioxide or this naphthalene get this much values, and the delta H values, this delta H fusion, delta H vaporization, delta H sublimation, whatever the value you are getting, these all the reactions are done experimentally, proof we are having, then we write that this much enthalpy changes is required. Okay, so let's solve one numerical. This is our NCERT numerical. A swimmer coming out from a pool covered with a film of water weighing about 18 kg, 18 gram. How much heat must be supplied to evaporate this water at 298 Kelvin? Calculate the internal energy of vaporization at 100 degrees Celsius. Now, see, there is nothing. What things are given here and what the things we have to calculate. Here, a swimmer comes, 18 gram liquid water is there. Okay. And this again 18 gram gaseous. Question you have understood? I hope you have understood. This is 18 gram liquid water and this is 18 gram gaseous water. Means here questions will calculate the internal energy of vaporization at 100 degrees Celsius. 100 degrees Celsius. What will happen? We have to represent the process through the evaporation only. Here the vaporization process from liquid to gaseous, right? Vaporization. Now 18 gram liquid has converted into the 18 gram gaseous. Now tell me what will be the number of moles? Number of moles you know very well. Number of moles in the mole concept we have studied. Given weight upon atomic weight 1 gram per mole. Number of moles is equal to 1 mole here, because 18 by 18, that is 1 mole, right? 18 gram H2 is given. Now after understanding about this, now tell me about the delta U vaporization. Your question is what will be the value of delta U, internal energy at vaporization. Now you can tell me what is this? This is nothing else except then the enthalpy changes minus P delta V. Have you remembered? In the enthalpy, what is the formula of this delta U is equal to delta H minus P delta V? Have you remembered or not? I hope you have remembered this formula. So here delta H is nothing else here from liquid to gases, so vaporization minus P delta V, and it is at 100 degrees Celsius. And according to ideal gas equation, P delta V, have you remembered the word that I have taught you in the equation, that is Ng delta RT? I hope you have heard. Yes, so what will be the here formula? Delta H vaporizations, enthalpy changes, minus delta N GRT. Is it right? PV is equal to nRT, from that only we have taken. So P delta V is equal to delta NGRT by using the ideal gas equation. So now here the values are given in the question, that delta H minus delta NGRT is 40.66 kilojoule per mole. How much? 40.66 kilojoule per mole. And you have to calculate the delta U value. So there is nothing else. You have to just put the value, how much number of gases are given, and the things. See, here it is given at 100 degrees Celsius. So for delta H vaporization at 100 degrees Celsius means 373 Kelvin. 373 Kelvin, it will be delta H is equal to 40.66 kilojoule at 373 Kelvin, means 100 degrees Celsius, that is 373 Kelvin. So delta H vaporization's value is equal to, how much it will be? 40.66 kilojoule per mole. 40.66 kilojoule per mole. Okay. So now you have to just calculate the value of delta U. So delta U is equal to 40.66 kilojoule per mole minus, how many number of moles is there? The number of moles is 1. What is the value of R? You know very well the value of R. Everybody know? 8.314. 8.314. And temperature is at 100 degrees Celsius, that is 373 Kelvin, right? 373 Kelvin, and you have to convert this into 10 to the power 3 kilojoule per mole here. Now tell me what will be the value. After equating this all, you will get 3.10. How much? 3.10. So 40.66 minus 3.10. And you know value of what is the SI unit of delta U, that is per mole, that is 37.56 kilojoule per mole. 37.56 na? Yeah, 37.56 kilojoule per mole. See, that was what the things were given here. From liquid to gases, a swimmer came from liquid and he has heated his body at 100 degrees Celsius. Now you have to just calculate the internal energy and delta H vaporizations here at 100 degrees Celsius is 40.66 kilojoule per mole. So by easily you can calculate this, and this type of question if it is given, then you don't have to worry about it. Here easily you can solve these questions. Got it everyone? Now there is a new topic called standard enthalpy of formation. See, there are so many this standard till the Hess law. There are standard enthalpy of formation, thermochemical equations, and then there is Hess law. So I hope this, first of all, click a screenshot of this. It is already given you NCERT. If you have, then there is no need to worry about it. And as you know about this vaporization, in the next video I will discuss about standard enthalpy of formation. See, whatever you are reading, that is enthalpy, either enthalpy changes, enthalpy formations, and whatever the things you are reading, just try to understand the concept. As you understand the concept, now you will understand the law. As you understand the law, you can definitely go ahead. Whatever you are taking the knowledge, take a skill-oriented knowledge. Not only just the bookish knowledge, whatever you have taken, this is the formula, you are calculating the value and finished. Not only till that. Whatever the uses are there of these things, where the uses are there. So that must be inside your mind. That's all for today. Thank you very much. Hope all of you have enjoyed this video. If you have liked this video, then don't forget to like and subscribe the channel. Share this video with your friends so they can be also benefited. Thank you very much.